Next, influence of the enthalpy change and entropy change over the spontaneity. Influence of del H and del S over spontaneity. Over spontaneity. Therefore, first enthalpy change, next entropy change, then del G. See, according to this expression, del G is equal to del H minus T ds. See, if the reaction wants to be spontaneous, finally the resultant of the enthalpy change and entropy change must become negative. So, for example, particular reaction is exothermic. If the reaction is exothermic, the sign of the enthalpy change is negative. That means the del H term, first term is negative. Next term, in that reaction, if entropy change is also negative, then if the entropy change is negative, inside the expression it becomes positive. Therefore, say for example, I will give one simple numerical value. If the enthalpy change is let us say minus 10. Next, if the temperature is let us say 1. Next, if the entropy change is let us say minus 10. If the entropy change is minus 10. So, this is minus 10, this becomes plus 10. So, therefore, resultant is 0. That means, if the enthalpy change is negative, if entropy change is also negative, and if the magnitude of the TdS term becomes equal to the enthalpy change, then the reaction becomes what is called, the reaction comes to the equilibrium. If the magnitude of the TdS become equal to magnitude of the enthalpy change, that means enthalpy change is negative, entropy change is negative, and if the magnitude of the TdS is equal to magnitude of the enthalpy change, then therefore del G is equal to 0. If del G happens to become 0, then we can say reaction is at equilibrium. Reaction is at equilibrium. Is at equilibrium. This is one case. Next, for a given reaction, enthalpy change is negative. Next, let us say entropy change is positive. If entropy change is positive, now just let us observe this small mathematical calculation. Say for example, enthalpy change is let us say this is minus 10. Enthalpy change is minus 10. Next, enthalpy change is minus 10. Next, entropy change is positive. If entropy change is positive, therefore, let us say temperature is 1. Let us say the entropy change is positive, and if the magnitude of the entropy change is equal to enthalpy change, let us say 10. This is minus 10. This again becomes minus 10. So, therefore, total value becomes minus 20. That means, if the enthalpy change is negative, entropy change is positive, then the free energy change compulsorily becomes the negative. Therefore, if del H magnitude is TdS, if it is either greater or smaller, therefore, del G is always negative. Del G is always negative. Reaction is always spontaneous. Reaction is always spontaneous. Reaction is always spontaneous. Next, so for a given reaction, so this is the reaction, this is the condition at which reaction is at equilibrium. This is the condition, reaction is always spontaneous. Next, another condition, reaction always non-spontaneous. So, when the reaction will be always non-spontaneous. Say for example, if the enthalpy change is positive, and if entropy change is negative. For example, according to this expression, according to this expression, enthalpy change is positive. Let us say I will give the value 10 minus, next let us say temperature is 1. Next entropy change is negative. Let us say I will give the minus 10. So this is a plus 10, minus of minus becomes plus 10, again plus 20. That means in any reaction, if the enthalpy change is positive, entropy change is negative, the reaction always becomes non-spontaneous. That means if del H either equal or greater than TdS, del G is always positive. Therefore, reaction is non-spontaneous. Non-spontaneous. Therefore, based on the enthalpy change and entropy change, we can predict the sign of the free energy change. So, under 3 conditions, so the reaction can be at equilibrium or spontaneous or non-spontaneous. For equilibrium condition is enthalpy change must be negative, entropy change must be negative, but their magnitudes must coincide with each other. Here enthalpy change and entropy change you observe, enthalpy change is negative, entropy change is positive, but here whether the magnitude of the two terms are more or lesser to each other, that is immaterial, then free energy change becomes the negative. Therefore, the reaction is always spontaneous. Here similarly, if you observe the enthalpy change and entropy change, say enthalpy change is positive, entropy change is negative. Therefore, here also the magnitudes of the two terms need not be either equal or greater. Whether they are equal or greater, del G always becomes positive, the reaction always becomes non-spontaneous. Next, let us discuss about the other conditions at which the reaction can become spontaneous or non-spontaneous. For example, enthalpy change is positive. Enthalpy change is positive. Next, let us say entropy change is also positive. Entropy change is also positive. Therefore, if you observe this expression, del G is equal to del H minus TdS. Whenever if the entropy change is positive, inside the expression it becomes negative. Inside the expression it becomes negative. Therefore, the resultant of these two terms depends on the magnitude of the enthalpy change and entropy change. For example, here enthalpy change is positive, del S entropy change is also positive, but if the magnitude of the TdS is greater than enthalpy change, if enthalpy change, magnitude of the enthalpy change and the magnitude of the entropy change, if you compare, if the magnitude of the entropy change is more, if it is more, the del G will become negative. Del G becomes negative, therefore, the reaction is spontaneous. Reaction is spontaneous. Similarly, enthalpy change is positive, and if entropy change is also positive, next if the magnitude of the enthalpy change is greater than the magnitude of the entropy change, then the del G will become positive. Therefore, reaction is non-spontaneous. Reaction is non-spontaneous. Next, third case, enthalpy change is negative. Next, entropy change. Entropy change is also negative. Entropy change is negative. Enthalpy change is negative. Entropy change is negative. Next, if compare the magnitudes of the two terms. Here, both the terms are negative. If the enthalpy change is magnitude of the enthalpy change is more than this one, now the del G will become, del G becomes negative. Therefore, the reaction is spontaneous. Reaction is spontaneous. Next, similarly, enthalpy change is negative, entropy change is negative. If the magnitude of the enthalpy change is less than the magnitude of the entropy change, then del G becomes a positive, therefore the reaction is non-spontaneous. So therefore these are the various possibilities through which the enthalpy change and entropy change can influence the magnitude of the del G. Therefore based on this resultant of the enthalpy change and entropy change, if we calculate the free energy change, whenever if we get the free energy change positive, we can say reaction is non-spontaneous. Whenever if we get the entropy free energy change negative, we can say reaction is spontaneous. So based on the sign of the free energy change, we can predict the spontaneity of the reaction. Next, relation between the change of free energy and composition of the reactants during the course of the reaction taking place at constant temperature.